Now, next, chapter 4, Principle of Mathematical Induction. This is sometimes also called just mathematical induction or PMI, or it is also called sometimes induction hypothesis. Induction hypothesis. Induction hypothesis. Okay. Now, the first question is, what is PMI and why PMI? So normally the PMI is used. Let me write, then I'll explain what is PMI. Principle of mathematical induction. PMI is used to prove, or you can write verify the results or statements defined on natural numbers, defined on n, remember. So the first thing is, here PMI is applicable only when you have some results which are defined on natural numbers, that is only on positive integers. We normally PMI is used to prove, or you can say verify, the results or the statements which are defined on natural numbers. For example, here, can I prove this using PMI? You know, sine square x plus cos square x equals to 1. You know this. And this is true for every x belongs to R. For every real number, you know this is true. So can you prove using PMI? The answer is no, obviously. Using PMI, can we prove this? The answer is no. This statement, or you can consider this as a formula, or you can consider this as a result, but this is true for all real numbers. So can we prove this result using PMI? The answer is no. You cannot prove using PMI, because here the statement is defined on natural number, real numbers, remember. So PMI is not applicable here. So that's the first thing. Here's everywhere in the exercises or in the question itself, you will find some results which are defined on where? Natural numbers. So what is PMI? So we write here, or what we will do here in the PMI, the principle of mathematical induction. The principle of mathematical induction, PMI. So what we do here, we take a statement defined on natural number as Pn. Suppose the statement here, let the statement be Pn here, P of n. Right? Given statement we consider as Pn, P of n. This is read as P of n. Let's consider the statement as P of n, where obviously what is this n? N is any natural number, as I told you. PMI is applicable only when the statement is defined on natural numbers. Okay. Then here there are two steps. The first step is, first show that, you need to prove this, show that P of 1 is true. P of 1 is true. What is the meaning of this? That is, for n equals to 1, this statement must be true. Statement must be true. Must be true, sorry. What is the first step? The first step is this. What it says, show that, you need to show, remember, show that P of 1 is true. What's the meaning of this? That is, for n equals to 1, that means in the given statement, instead of n you put 1, and show that the statement must be true. This is what you need to show, remember, that's what you need to show. That is, I'll write, that is for n equals to 1, prove that LHS equals to RHS. in the given statement. That's the one thing. Now what is the step number 2? That's very important step here. Step number 2, second step, that is here, let me write. In the second step, we assume that the statement is true. This is our assumption. You are not going to prove that. Assume that P of K for any K belongs to N, for any K belongs to N, P of K is true. This is your assumption, remember. For any natural number K randomly, you show that the P of K is true, right? And with the help of this, we show that with the help of this is our assumption. In the second step itself, now you need to show that. We show that P of K plus 1, that is the next number. Here it was K, here it is K plus 1. P of K plus 1 is true. That is what you need to show. That is, you need to show that for n equals to K plus 1, in the given statement, we must have LHS equals to RHS. I repeat the second step. What is the second step? Second step says that you first assume that for K, that is P of K, must be true. Number 1. Additionally, what else you need to show? This was your assumption, remember. Here, this is not proof part. This is the proof part, and this is the only important part in each PMI question. We show that P of K plus 1 is true. This you need to show, remember. What's the meaning of this? That means in the given statement, instead of N, you put K plus 1 and you start with LHS and get the RHS. Right? That's what you need to do. And once you show these two steps, what are the first step? Step number 1 says, what is the step number 1? Step number 1 says that the first prove for 1, assume for K, and prove for K plus 1. You prove for 1 here, step number 1, prove for 1, assumption for K, and prove for K plus 1. Once you do this, you can say that the given statement must be true for all n belongs to n. Then this is the conclusion. Then what's the concluding line here? Then P of n means given statement. P of n is true for all n belongs to n, that is for natural numbers. That's all in all about PMI, right? I'll repeat the PMI, principle of mathematical induction. What you need to do, you take the given statement as Pn. That's the first thing. Take the given statement as Pn. I'll take one example, you'll realize immediately. Prove for 1, assume for K, and prove for K plus 1. What's the meaning of this? Is the most important part in PMI sums, remember. What is meaning of prove that P of K is true? It means you choose n equals to K plus 1, start with LHS and get the RHS. And once I show these two steps, these are the two steps of the PMI, the conclusion is then the Pn must be true for all n. The given result defined on natural number has to be true for every number, remember. Right? That's what all in all about the PMI. Okay. So what I'm trying to tell you is this here. Again, you take the statement as P of n, prove for n is equal to K, n equals to 1, show LHS equals to RHS where in the given statement. Second step is assume for n equals to K. This is your assumption. So for n is equal to K, statement must be true. Pk is true. pk is true. This is your assumption. And the most important part is show that p of k must be true. Show that n equals to, if I put k plus 1, the statement must be true. The statement, which statement? That is pn statement. Statement pn, that is k plus 1, is true. How do you show this? In the given statement, start with LHS. Put n is equal to k plus 1. Whenever you have n, put k plus 1. And at the end, you get RHS. Right? Once you show this much, you can say that the statement Pn is true for all n belongs to n. For all natural number, the statement must be true. Right? Okay. With this, let us start with first example. So let us take example number 1. The question is, using PMI, using principle of mathematical induction, prove that 1 plus 2 plus 3 plus 4 up to n equals to n into n plus 1 by 2. This is very well known result for natural numbers, where obviously n belongs to n, remember here. This is for natural numbers. What you want to prove using PMI? 1 plus 2 plus 3 up to n. This n can be any natural number, remember. N can be 20. So 1 plus 2 plus 3 up to 20. That is 20 into 21 by 2. Right? That way you can find the sum of the natural number like this. For example, if you want to find 1 plus 2 plus 3 plus 4, you can find directly here, because you have just 4 natural numbers. 4 plus 3 7, 7 plus 2 9 plus 1 10. But you can use this formula here. So I'll put 4 here. 4 into 4 plus 1, 5 by 2. So you see you are getting 10. Right? This way this formula can be used. Suppose I have this one, 1 plus 2 plus 3 up to 10. This means sum of the first 10 natural numbers. So it is given by 10 into 10 plus 1, which is 11 by 2, 110, which is 55. So this is very well known formula. We'll show this by PMI, that this is always true. This is our statement, remember. Which is our statement? This one. This is called our statement. 1 plus 2 plus 3 up to n. It is n into n plus 1 by 2. We prove with the help of principle of mathematical induction. Okay. So in the solution, we start with this. This is a standard flow of solution in every question, remember. All the questions have similar pattern. So I'll call that as P of n, colon 1 plus 2 plus 3 up to n, which is given by n into n plus 1 by 2. This is a statement. We want to prove that this equals to this using principle of mathematical induction. So what is the step number 1? You choose n equals to 1 first. Choose n equals to 1 and you show that LHS equals to RHS. So for n equals to 1, this is the first step. For n is equal to 1, what is LHS? You put here 1, that is only one term. So LHS is, put 1 here, that means summation is up to 1. What about RHS? 1 into 1 plus 1, 2 by 2, so 1. So LHS equals to RHS. That is the step number 1. So therefore, what is the conclusion? In this statement, in place of n equals to 1, if I place, then I'm getting LHS equals to RHS. So therefore, you can say that the P of 1 is true. That is 1. P of 1 is true. So in one part you are through. Now we go to step number 2. We assume that P of k is true for k belongs to n. Now what's the meaning of this? I'm writing the meaning of that. That is, in this statement, in place of n, if I put k, then I get the LHS equals to RHS. So 1 plus 2 plus 3 up to k equals to k into k plus 1 by 2. Right? What I did, this is very simple. Just in the given statement, instead of n, you put k. I did nothing. See, what's the meaning of p of 1 is true? In place of n equals to 1, if I put in the statement, then I'm getting LHS equals to RHS. Now here, what is the assumption? Assume that the p of k is true. What is the meaning of this? In this formula, instead of n, you put k. Wherever you find n, just place the k. So here k, here k, here k, plus 1 by 2. We call this as 1. Right? This is our assumption. Always we call this as 1. Okay. Now, the most important part is we prove. ये prove करना है, remember. We have proved for 1. We have assumed for k. And we prove for k plus 1. So we prove that the p of k plus 1 is true. This is what you want to prove. Okay. So as I explained, what do? We start with LHS. What is LHS here? 1 plus 2 plus 3. You want for k plus 1. So I'll write the last term, which is k plus 1. Because आप किसके लिए prove कर रहे हैं? K plus 1 के लिए prove कर रहे हैं, remember. So what I did, I just wrote this. But instead of n, क्या place किया आपने? K plus 1. क्यों? Because you want to prove for k plus 1. Okay. Now, we simplify this and we get this RHS. But यहाँ पे n की जगह पे automatically k plus 1 आपको दिख जाएगा. Okay. So 1 plus 2 plus 3. The last term is k plus 1 here. So what is the previous term? That is k. Right? See. Here 3. What is the previous term? 1 less 2. 2. What's the previous term? 1 less 1. Your last term is k plus 1. So what's the previous term? That's k. Okay. Now this much you already proved. You know this 1 by 1. 1 plus 2 plus 3 up to k आप जानते हैं, era 1. कितना है 1 plus 2 plus 3 up to k? That is this portion. So I'll place here. Fine. So here, if I place this, if I continue with this here, this is equals to, I'm putting the value of this portion. Which portion here? This portion, remember. 1 plus 2 plus 3 using 1. So what I'll get here? K into k plus 1 by 2. This k plus 1 as it is. Okay? I write here because of 1. What I did, I repeat again, instead of this, with the help of 1, I have placed this portion. Always will do like this, remember. This is very standard flow of solution. Now we simplify algebraically. So you take 2 as LCM and you can find k plus 1 common. I'll find k plus 1 common. So you have k by 2 from here and 1 from here. K plus 1 common. Take LCM. So k plus 1, k plus 2 by 2. So if you want, you can just rewrite like this here. How do I rewrite? K plus 1 into k plus 1 plus 1 by 2. Dekho, you see, have a look on right hand side. RHS aa gaya. What's the meaning of we prove k plus 1? Put n equals to k plus 1 where? On the LHS. So on the RHS also, instead of n, you must have k plus 1. You see here, you are getting k plus 1. Right? N here, that become k plus 1. These n become k plus 1. So this is your RHS. Right? Everywhere instead of n, now it become k plus 1. And therefore, what's the conclusion? P of k plus 1 is true. And once you show this one, you can say that by PMI, by principle of mathematical induction, the given statement Pn is true for all n belongs to n, for all natural number. That's all in all about PMI. As far as 11th standard concerned, you have this much only in PMI. repeat again what I did. Let me repeat. I have started with the Pn, call the given statement as Pn, prove for n is equal to 1, assume for n is equal to k, and again prove for n equals to k plus 1. If you show this much, you can say that the Pn is true for every n. Pn is true for every n. So now you can say that Pn means which statement? This one. Right? This statement is always true. That you can say. Now this statement is always true. You have verified using PMI that this is always true. The one question in your mind that from where this result has come, that may be by experiment or some another technique, but you have this result. So PMI is one of the method of verification that the some result you already derived by some experiment or observation whether this is always true or not. Remember, PMI is one of the method of verification. Remember, let me write here, PMI is a method of, you can say method of verification. What's the meaning of verification? That is, derived result is true or not. Method of verification. You can see whether the derived result is always true or not. So now once you conclude this, you can say that this is always true. So you can use this formula always now. If you want to get this summation, for example, if I want to do this 1 plus 2 plus 3 up to 100, then I can use this formula now. What is that formula? 100 into 101 by 2. You simplify this. This gives us sum of the first 100 natural numbers. Fine. So there is one question. Now, so I'll go to now exercise 4.1 here. How do we solve all these questions? Same procedure what I did in the previous example. So question number 1, I'll call that as Pn. Let P of n be this 1 plus 3 plus 3 squared up to 3 raised to n minus 1 equals to 3 raised to n minus 1 by 2. We want to prove this using PMI. Question is this: prove the following using principle of mathematical induction, and this is defined for natural numbers. It is understood when you use the PMI. Okay, so step number 1, for n is equal to 1, write LHS. What is the left hand side? Put n is equal to 1 here. So 3 raised to 1 minus 1, that is 0. 3 raised to 0, that is just 1. So LHS is 1. What is RHS? Put n is equal to 1 here. 3 raised to 1 minus 1 by 2. So that is also 1. So therefore LHS equals to RHS. And therefore P of 1 is true. This is the first part, which is very simple. That means the statement is true for n is equal to 1. Right? It's very simple. Just put n is equal to 1 on LHS. RHS, you notice that the both are equal. So P of 1 is true. Now for n is equal to k, we assume that the statement is true. We assume that P of k is true. This is our assumption. We assume that the P of k is true. So what is the meaning of this? That is, I'm just writing the meaning of this. That is, in the statement, instead of n, you put k. So 1 plus 3 square and so on up to 3 raised to, instead of n, k minus 1 upon 3 raised to k minus 1 by 2. And we always call this as 1, you know. As I did, we call this as 1. We will use in the next proof. That's in the proof of P of k plus 1. So this is our assumption. How we got this? In the given statement, instead of n, you put k. So we have this. Now, most important part is this. We prove this, you are going to prove This were an assumption, and this is what you had proved, that the P of k plus 1 is true. This is what you want to prove. Okay, so as I did in the last example, start with LHS k plus 1. So there in the left hand side, instead of n, you write k plus 1. So I'm writing 1 plus 3 square and so on, 3 raised to, instead of n, k plus 1. So it becomes just k plus 1 minus 1. So this will goes away, so you are just left with k. Right? Okay. Now, as we did in the previous example again, what we do in the next step? We write the previous step. 1 plus 3 square. Here see, 3 raised to 2. Previous one is 3 raised to 1. That is one less power. Your last term is 3 raised to k. So what's the previous term? That is k minus 1. It is always this, remember. Previous term. This is last. I wrote the previous term. Why I wrote? You know, because I know this much by 1. By 1, I know this much. What is this by 1? This is equals to, here, this one. So 3 raised to k minus 1 by 2 plus this one is already there. So what I'll write here in the reason? I'll write because of 1. I'll write because of 1. This portion is because of 1 here. In place of this one, I've placed this. Okay. Now we just simplify. So you're almost through, remember. So how do I simplify? I'll take LCM here. 3 raised to k minus 1 plus 2 into 3 raised to k upon 2. So here, this is 2 times 3 raised to k, here 3 raised to k. So if you combine this one and this one, what I'll get? I'll get 3 into 3 raised to k. This is like 2x and this is x, so it is 3x that way. Minus 1 as it is upon 2. Now here 3 raised to 1, 3 raised to k. So what I'm getting? Here finally, let me write here only. So what I'm getting finally? 3 raised to, adding powers, k plus 1 minus 1 by 2. And you see, this is nothing but your RHS. What should be your RHS? What should be your RHS? In this formula, instead of n, you must have k plus 1. That's what you are getting. You can check 3 raised to k plus 1 minus 1 by 2. So this is RHS. And therefore, you can say that, therefore, you can say, what you can say? P of k plus 1 is true. And once we show this, we can say by PMI, therefore, by principle of mathematical induction, PN means given statement, is true for all n belongs to n. By PMI, PN must be true for all natural numbers. Fine. Okay. Let's go to next example. Example number 2. Second example. Let's take Pn as the statement, given statement. What do you want to prove? 1 cube plus 2 cube up to n cube equals to n into n plus 1 by 2 the whole cube. The whole square, sorry. The whole square. This is your Pn. Pn means given statement. Now recall what is the first step? Prove for n is equal to 1. Third time we are doing the same thing. So for n equals to 1. What is LHS? Put 1 here. So it is up to this 1 cube, which is 1. Okay. What about RHS? Put n equals to 1. 1 into 1, that is 2 by 2 the whole square. So it is again 1. So therefore LHS equals to RHS. So therefore what's the conclusion? In this statement, if I put instead of 1, I'll get LHS equals to RHS. So therefore P of 1 is true. This is the first part. Step number 1. This is very simple step, you know. What's the next step? we assume that this is the assumption part. Remember, we assume that P of K is true. This is the assumption part, remember, where K belongs to N. What is the meaning of this? That is, I'm writing the meaning of this. That is, again I'm emphasizing, in the given statement, instead of N, you put K. So 1 cube plus 2 cube up to K cube equals to K into K plus 1 by 2 the whole square. We always call this as 1, you know. We always call this as 1, as I did in previous 2 example. How I got this? In the above statement, in place of N, you put K. Above statement means Pn. Okay. Now, next important part, we prove for N equals to K plus 1. That is what we are going to prove. I mean, that is, you are going to prove P of K plus 1 is true. This is what you want to prove. You want to show that instead of N, if I put K plus 1, I'll get LHS equals to RHS. This was your assumption, remember. This is not you have derived. That's why I wrote directly. But here you are going to prove. So always from where we start? LHS. So what we do? Here I'll write instead of N, K plus 1, 1 cube plus 2 cube up to, in place of N, K plus 1. So K plus 1 the whole cube. What we do, as we did in previous 2 example, we always write the previous term. 1 cube, 2 cube. Last term is K plus 1 the whole cube. What's the previous term? That is K cube. In this one, you write 1 less. You see, 2 cube, what's the previous term? 1 cube. So 1 less. Why we did this? This term is always in fact this, remember, as you must have realized in previous 2 example. Why we did this? Because you know this much. What is this? By 1 here, you can write K into K plus 1 by 2 the whole square, and this portion as it is, K plus 1 the whole cube as it is. Now, just simple algebra, we simplify. So let me simplify this here. If I further simplify, this is equals to what you can find common. You can see K plus 1 the whole square is common. So what we are getting here? K square by 4 plus K plus 1. 1 K plus 1 you are left here. Right? Taking K plus 1 the whole square common. So K square by 4 and 1 K plus 1. We simplify this bracket. So here you will get the K square plus 4K plus 4, just taking LCM upon 4. This expression you must have realized it's a perfect square. K plus 1 the whole square into K plus 2 the whole square by 4. Now what is this? In turn, if I write K plus 1 the whole square, K plus 1 plus 1, okay, let me rewrite, the whole by 2 the whole square. So what you are getting, this is what your exactly RHS. That's what you wanted. What you wanted in this formula here, you wanted instead of N here K plus 1. You wanted here in place of N here K plus 1, here K plus 1. That's what you are getting. You see, K plus 1, K plus 1 plus 1 as it is by 2 whole square. So therefore, what's the conclusion? P of K plus 1 is true. Therefore, P of K plus 1 is true. And therefore, by PMI, Pn is true for all n. all n belongs to n. So statement is always true for every natural numbers. Fine. Next, I'll go to ninth question. Let's see ninth. Let's take Pn as 1 by 2 here, plus 1 upon 4, plus 1 upon 8, and so on. 1 upon 2 raised to n equals to 1 minus 1 upon 2 raised to n. This is what you want to prove using principle of mathematical induction. Okay, so step number 1. For n is equal to 1. Write LHS. What is LHS? Put n equals to 1. So I'll put n is equal to 1. So you are getting just 1 by 2. So that is up to this. 1 by 2. That is first term alone. What is RHS? Here 1 minus 1 upon 2 raised to 1, which is again 1 by 2. So therefore LHS equals to RHS. And therefore P of 1 is true. So statement is true for n equal to 1. What is the next step? That is our assumption. We assume that the P of k, where k is any natural number, is true. What is the meaning of P of k is true? That means, that is, just we write the meaning of this. That is, in the statement, instead of n, you write k. So 1 by 2 plus 1 upon 4 and so on. 1 upon 2 raised to k equals to 1 minus 1 upon 2 raised to k. Instead of n, you write the k. This is 1, as we did. This is 1. What I did? In the Pn statement, instead of n, I wrote k. Now next part. What is next part? We prove that the P of k plus 1 is true. What is the meaning of this? That means we start with LHS here. Instead of n, we write k plus 1. We get this, but instead of n kya milna chahiye? K plus 1 milna chahiye. That's all in all. So what is left hand side here? 1 by 2 plus 1 upon 4 plus 1 upon 8 and so on up to 1 upon 2 raised to k plus 1. Okay. Now, how I got this? Again, fourth time. Instead of n, I wrote k plus 1. Now always, as we did, we write the previous term. The last term is 1 upon 2 raised to k plus 1. What is the previous term? 1 less power, that is 1 upon 2 raised to k. This term is always this, remember. Okay. Then, you know the value of this 1 by 1. What is that value? 1 minus 1 upon 2 raised to k plus this one as it is. This is because of 1. What you want to prove, that should be in your mind. What should be our RHS? RHS should be this one, but instead of n, you should have k plus 1. So our RHS should be this, remember. Right hand side should be this. RHS A मिलना चाहिए, but n के जगह पे क्या होना चाहिए? K plus 1 होना चाहिए. Okay, so keep this RHS in your mind, remember. Okay. So here, now simplify this. 1 minus, that much you need. So don't disturb this because you need 1 minus. This is 1 upon 2 raised to k. This I can rewrite as 1 upon 2 raised to k into 2. And you can find this much common. 2 raised to k you will find common. So here you are left with 1. I took minus common. So minus 1 upon 2. Fine. What I did? I have just taken 2 raised to k common. So here 1, because of this minus you are getting minus. So this is equals to 1 minus 1 upon 2 raised to k. Here you are left with 1 by 2. So this is equals to 1 minus 1 upon 2 raised to k plus 1. So that's what you are getting. That's what you had expected. You see, instead of n क्या मिलना चाहिए, k plus 1 मिलना चाहिए, and you got it. So this is nothing but your RHS. This is your right answer. So therefore, you can say that if I write the next step here, therefore, what I can write? P of k plus 1 is true. And therefore, by PMI, you can say that the given statement must be true. PMI, Pn is true for every n. Pm is true for all n belongs to n. I hope now PMI must be clear too. Okay.